In 10.5, we're going to continue learning about angle relationships in circles. So the first kind of relationship we're going to learn about is when you happen to have a circle and a tangent line. So it's called tangent and intersected chord theorem. And it says that if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So again, what it's saying is here is this tangent line that touches the circle at the point of tangency. And if you notice, you're basically going to get one angle over here, angle 1, and angle 1 has this intercepted arc. And you're going to get a second angle, angle 2 here. And then that second angle also has this intercepted arc over here. Well, if you think about it, notice that these angles, right, are angles that have a vertices on the circle. And so when the vertices is on the circle, remember that the angle is always half of the intercepted arc, or the arc is double the angle. So it's really no different. It looks a little different than what we did in the last slide, but it's the same concept. Okay, so I know that angle A here is half of arc AB, and angle 2 here is half of arc BCA or ACB. So let's just work on this one. So again, let's say we have a circle and we have a line that's tangent to the circle, like that. Okay, and let's say this is our point of tangency, and I kind of create this angle here. And I ask you and I say, okay, well, what is the measure of this? Let's say this angle is 50 degrees. And I say, well, what is the length then of this arc? Well, again, the arc is going to be 2 times 50 or 100 degrees. Okay, it's going to be double. If I tell you that this arc from here to here, let's say that arc measures 260 degrees, and I say, okay, well, what is the measure then of this angle? It's half of that, which is 130. Know that when you do this, remember that the arcs, okay, all the arcs, all the way around the circle, that's always going to add up to 360. So the 100 and 260 makes sense that it adds up to 360. And notice that this tangent line, okay, is always going to be a straight line and add up to 180 degrees. So these two angles will always end up adding up to 180. So I'm going to pause here and I'm going to move on to a subsequent slide to work on some of these problems. So now what happens, the third kind of angle that remember that we've talked about angles before. We've talked about central angles where the vertex was the center of the circle. Okay, we've talked about inscribed angles where the vertex was on the circle, right? Which is the kind of the same situation that just happened with that tangent line. Now, what happens when you have two chords that intersect inside, and notice that the vertex of the angles, like angle 1, here's the vertex, and angle 2 has the same vertex, right? And so notice that the vertex is in the circle, right? The vertex is in the circle, but not in the center. So it's not on the edge like that an inscribed angle. It's not in the center like this one. It's in the circle but not in the center. So what happens, how do we figure out our angle measures and our arc measures when we have this scenario? Well, angles inside the circle theorem says that if two chords intersect inside the circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So that's a lot to read. All it's saying is this. Angle 1 over here, angle 1 is going to equal half the sum, okay, half of the sum of arc whatever DC is, plus arc AB. That's it. And then angle 2 is going to equal half of the sum of BC, arc BC, plus arc AD. And that's how you do that. So it's, again, half of that. So let me just give you kind of like, let's just do a couple problems so we can work that out. So let's just say that arc AB is 40 and arc DC is 60. And I want to know what the measure of angle 1 is. Well, angle 1 is going to equal half of 40 plus 60. So it's going to equal half of 100, or 50 degrees. So this is 50 degrees. Once I know that that's 50, I can solve everything else. Vertical angles are equal, so that one's 50. And I know that this forms a linear pair, which are supplementary, so this is 130, and this is 130, and I can figure out everything else, right? But again, so basically half of the sum is basically the average. So 40 plus 60 adds up to 100. 100 divided by 2 is the same as times a half. So it's the average of the arcs. And then we've got the last scenario, or one of the last scenarios, I think, where what happens if you have two lines and the angles meet, and the vertex of the angle, the two lines intersect, and the vertex is outside the circle. So remember, we've been dealing with we started this whole thing with central angles where the vertex was in the center, right? Then we did intercepted where the vertex was on the circle. Then we did, well, the vertex is in the circle, but not in the center. And now we're talking about two lines that meet outside the circle. So those lines that form it, it could be two tangent lines like this one. These are two tangent lines. It could be two secant lines like these. These are two secants. Or it could be one tangent line and one secant line. But no matter what it is, the vertex of the angle formed, no matter what the lines are that created it, the vertex is always outside the circle. So when the vertex is outside the circle, okay, the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So again, let me show you what that means. Notice here you have arc Y is in between those angles, those sides, and arc X. Now arc X, notice, is bigger than Y. So how I do it is I say the measure of angle 1 equals half the difference of the big arc minus the little arc. That's how I set it up, okay? You could say the farthest arc away minus the closest arc. So again, in this one, it's going to be half of X minus Y. That's what angle 1 is going to equal, okay? Now, if I come to this second one, again, notice this is two tangents, but still you've got, from here, you've got arc Y, and you have here, you know, arc X. And again, it's the same thing. It's going to be angle 1 equals half of the big arc, which is X, minus the little arc, which is Y. And lastly, if you have a tangent and a secant line, same scenario, you end up with a big arc X and a little arc Y. And so you know that it's going to be, angle 1 is going to be half of X minus Y. So again, I do it as big arc minus little arc. A circumscribed angle, well, that's an angle whose sides are tangent to a circle. Again, it means basically that the angle is outside of the circle. And when you have a circumscribed angle, there is a theorem that works. If you don't remember it, it's okay because you can solve it in a different way. However, it is a shortcut. So what happens is if you happen to have this angle here, notice that you've got this angle outside of this circle. And again, if I wanted, for example, to find the measure of angle ADB, this one here, angle D, right? I know that angle D is 1/2 the big arc, right? Big minus little. So in this problem, I know the big arc is A to B out here, right? And the little arc is A to B this way, right? I would need some extra point here to label for the big arc. But I know it's the red arc minus the blue arc in this picture. But notice, I'm not really given a whole lot. I don't have those arcs, right? Well, what happens if, obviously in a real problem, I would be given the red arc or the blue arc or whatever to find this. But what if I'm not given the arcs, right? There wouldn't be another way, or we wouldn't know another way. Well, there is one special way. And what happens is we can go back to something we learned before. We learned, for example, that a central angle, right? If this is a central angle, because this is the center, whatever this measure is, let's say this is 50, right? Well, then we know that this arc here, if it's a central angle, we know this also has to be 50. And if that's 50, then, for example, we know that the whole rest of it is 310, so this big arc is 310, and now we can solve the long way. This is still like the long way, right? If we're given this central angle, we could come here and we know that angle D is 1/2 the big arc minus the little arc, so it's going to be 1/2 of 260, which is going to equal 130 degrees. So this is a way we could solve it because we know about central angles. We know if that central angle is 50, we know how to find the arcs. But there's even a shorter way, and this is what the theorem is telling us. The theorem says if you happen to know what this central angle is, right, this arc right here, this angle D, is going to equal 180 degrees minus the central angle. And so we know straight off that it's 130. And we didn't have to do the whole big minus little and figure out that this was 310. So it's a shortcut when you have a circumscribed angle. It only works for the circumscribed angles, and so it's one shortcut of this process. So now we're going to apply all the things that we learned, and we're going to try to figure out all the missing pieces. So the first thing it's asking us for is the measure of arc WT. So it's asking what is WT. So WT is our unknown here. Let's call it X. Notice that we know this is 30. And notice that this angle that's 30 degrees is made from this angle here. So what happens is that we have this large arc far away, which measures 100, and then the smaller arc, X, is what's missing. So basically, I know that angle U, right? Angle U is going to equal 1/2 of the big arc minus the little arc. So in this case, angle U is 30 degrees, the big arc is 100 degrees, and the little arc is X. So I just need to solve for X algebraically. So first thing I'm going to do is multiply both sides by 2, because that's going to get rid of that fraction. I'm going to get 60 equals 100 minus X. When I subtract 100 from both sides, I get negative 40 equals negative X, which means X is positive 40. So I know that this little X right here, this arc, is 40 degrees. So that is a good start to this problem. Now the second thing is, and this is just a habit that I do, if I already have 3 of the 4 pieces of these arcs, I basically have 3 of the 4 arcs. I know all the arcs have to add up to 360 degrees. So this arc is 110 degrees. Then I've got 40 degrees. Then I have another 100 degrees. So far I have 250. I know all of the arcs have to add up to 360. So when I subtract, I know this missing arc is equal to 110 degrees. So arc RS here is 110 degrees. So now I have all my arc pieces. So then I notice the next bunch of questions is asking me about angle measures. So let's just pick one to look for, right? So we're going to say, okay, wants to know what is the measure of angle TVS? Well, that's this angle here. Well, notice that the vertex of this angle is in the circle, but not in the center. And so the formula for the angle, so angle TVS, because it's in the circle, but not in the center, it's half of the average of the intercepted arcs, which is the 100 here, plus the 110 there on the other side. So TVS is half of 210, or 105 degrees. So this angle is 105 degrees. And then the last question asks us about the measure of RVS. Now we could do the same formula as we did here. We could do it again. We also can take a little bit of a shortcut because we know that this entire angle has to add up to 180. If this piece is 105, this piece is 75. And so I know that RVS is 75 degrees without really doing all the math. However, if I wanted to do the math, I could, because again, we know how to do the math. We know that this angle here, RVS, angle RVS, is going to equal half the sum of 110 plus 40. It's half of the intercepted arcs, or the sum of the intercepted arcs. So it's half of 150, or 75, which we had already found. So again, you can use multiple methods. You don't have to use the new stuff if you know that a linear pair equals 180, and so you can just apply that skill. Okay, so now we're here at this one, and it's asking us if the measure of arc AB is 105 degrees, then angle D, the measure of angle D, equals what? So let's just figure out here what is arc AB. So AB is here, right? So from here to here, this is 105 degrees. Okay, well, then we've got the rest of it, right? Notice that this is what we're talking about here, right? Here is our thing, angle D. So we know that ACB is the rest of this, right? So if the red piece is 105 and the whole circle adds up to 360, I know that this is 255 degrees. So the long way to do this problem is angle D equals 1/2 the big arc minus the small arc. Whoops. Right? And so it's 1/2, and this gets me to 150, which is 75 degrees. So I know that angle D is 75 degrees. That's the longer way. Now, what you could have also noticed in this one is that this is one of those special cases where it's made up of, notice these are two tangent lines, and basically the circle is kind of inscribed within them, because these lines kind of go out like that. And so the angle is circumscribed about the circle. So we're like, well, how would this be different? Well, this is that special case where basically if you just make this a central angle, if this is 105 degrees, you know the central angle is 105 degrees as well. And remember that in this case, angle D is 180 minus the central angle, which is 75. And so again, this was that shortcut we learned about on that last slide. So this was the longer way, this was the shortcut. Either one would work here. And then again here, they're asking for the measure of arc AB. So again, what they're wanting is arc AB. This is the unknown. This is our variable. Notice that's the big arc, this is the small arc, and this is the angle. So we know that the angle is going to equal half big minus little. So again, now I'm going to look at it, and the angle is 10, and it's half the big arc, which is x, minus the little arc, which is 20. And like I've done before, I'm going to start by multiplying both sides by 2 so that I can get rid of that denominator. So I get 20 equals x minus 20, and I just add 20 to both sides, and I'm like x equals 40. So x is 40 degrees, so the measure of arc AB is 40 degrees. And last but not least, find the value of x. So again, notice that this angle is circumscribed, right? It's around the circle. It's the two tangent lines. And so this is that special scenario where we know that angle x is going to equal 180 minus the central angle of 135. So angle x, or whatever, x is going to equal 45 degrees. And so that's your answer. That's the shortcut method. If you were to do it the long way, notice this is the little arc. The big arc would be from A to B this way. This arc would be 135. The larger arc would be 360 minus 135. So that's going to be 5 to, I think it's 225. And so angle D would equal half of the big arc minus the little arc. And so if I do my math correctly, let's see what it ends up being. That's 90. And then half of 90 is 45. And so I could have found it, again, doing it the long way, or I could have done it the shortcut. And that's it.